Today we're going to talk about writing equations of polynomials. So we're essentially working backwards from what we did yesterday. If I am looking at this graph, I see that I have a root at -3, 0. I have a root at 1, 0. And notice that this is a double root. So that's kind of important. And then I have a root at 3, 0. I also appear to have the y-intercept at 0, -1. So that'll probably help me graph this equation. So if I want to write the shell of the equation, y equals a, which is some leading coefficient that I'm not aware of. I know that I have a root at -3, so I can put x plus 3. I know I have a root at 1, so I can put x minus 1. And since it's a double root, I'm going to square it. And then I have a root at x minus 3. Or I'm sorry, I have a root at 3, so I have a factor of x minus 3. Now I'm going to substitute in 0, -1 into my equation. So -1 in for y and 0 in for x. And now I solve for a. So I end up with 9, or -1 equals -9a. So when I solve, I get a equals 1/9. And then I can write my final answer. My final answer for this problem is going to be y equals 1/9 x plus 3, x minus 1 squared, x minus 3. Notice that the leading coefficient is positive and it is a fourth degree polynomial, which makes sense because the end behavior goes up in both directions like that. Problem 2, I see that I have a root at -2, 0, a root at 1, 0, and this appears to be a dipty-do, so this is a triple root. And then I have a root at 5, 0. So if I want to start writing the shell of this, I will see y equals a times x plus 2 times x minus 1 to the third times x minus 5. Now I substitute in 0, 1, which is the y-intercept. So 1 equals a, substitute in 0 for all of these x's. And then I end up discovering that a equals 1/10 after I do a little bit of multiplying and math and stuff. So my final answer for number 2 is going to be y equals 1/10 x plus 2, x minus 1 cubed, x minus 5. Since this is a fifth degree polynomial and a is positive, that makes sense because on my graph, the end behavior goes down as x approaches negative infinity and up as x approaches positive infinity. Problem 3, it appears that I have two double roots. I have a double root at -4 and a double root at -1. So I have y equals a times x plus 4 squared times x plus 1 squared. A should be negative because notice my end behavior is going down in both directions. So I also have the point -3, -1. So I'm going to substitute -1 in for y and -3 in for x. So -3 goes in where x is. This is a little bit more challenging than when I have the y-intercept, but it's not too bad. So a times 1 squared times -2 squared. Notice -2 squared is 4. So a equals -1/4. And that's good because that was what was supposed to happen. I was supposed to get a negative value for a. So y equals -1/4 x plus 4 squared times x plus 1 squared. Fourth problem. I appear to have a y-intercept at 4, and then I have single roots at -2. So x plus 2, x plus 1, then x minus 1 is the value of 1 is a double root, so my factor x minus 1 is squared, and then I have x minus 2 is another factor due to my root at 2. I substitute in 0, 4. Because I know that point, I know that y-intercept, And so I realize that a, which should be a negative number because my end behavior looks like this on an odd numbered problem or an odd numbered degree. And then I see that a should equal, it appears to be -1 when I do the multiplication. So my final answer is going to be y equals -1, x plus 2, x plus 1, x minus 1 squared, x minus 2. And that's my final answer for this problem. One more thing to talk about on problems 1 through 4. If you're given a visual and you see that the end behavior looks in such a way, like for example in problem 4, you need to make sure that uh, your degree would end up being odd. And so a lot of people might forget this squared over here. And it's easy to check because if you see only a fourth degree polynomial, but your end behavior looks like this, then you know that there's something going on, and that's a good reason to check and see what's going on with maybe a double root or something. Okay, problems 5 and 6. Maybe. There we are. Write an equation for f of x if f of 2 equals 0. So notice that means the point 2, 0 is on the graph. F of 4 equals 0 means the point 4, 0 is on the graph. I also know -3, 0 and -1, 0 are on the graph. This one has multiplicity 2, which is another code word for double root. So I'm going to write down my equation. Y equals a times x minus 2 times x minus 4 times x plus 3 times x plus 1 squared. Then I know that -2, 36 is on the graph. So I'm going to substitute in 36 for y and -2 for x. So -2 minus 2 is -4. -2 minus 4 is -6. -2 plus 3 is 1. And -2 plus 1 is -1. So I end up with 36 equals 24a. So a equals 3/2. So my final answer will be y equals 3/2 x minus 2, x minus 4, x plus 3, x plus 1 squared. Last problem. Double roots at 1 and -1 mean that I have x minus 1 squared and x plus 1 squared in my equation. Those are my factors. And then I have single roots at -2 and -5. So I have factors of x plus 2 and x plus 5. I'm going to substitute in -3 for x and -8 for y, since I know that's a value. So -8 equals a times -4 squared times -2 squared times -1 times 2. So as I do this, I get -8 equals 16 times 4 times -2 times a. And then what I'll notice is that I can take these two, combine them to be -8, divide that over, and I get 1 equals 16a. Therefore, a equals 1/16. And then I can write my final answer. So y equals 1/16, x minus 1 squared, x plus 1 squared, x plus 2, x plus 5. And that's the final answer for that problem.